I'm Richard Wright with LunarG, curators of the Vulkan SDK, and I'm here with Bill Hollings from Brenwill. Bill is the creator of MoltenVK, a very important part of the Vulkan ecosystem on Apple and of the Vulkan SDK. And we're both here to talk to you today about using MoltenVK and Vulkan on Apple systems. First, I'm going to have Bill talk to you for a few minutes about MoltenVK, and then I'll talk more about using MoltenVK in the SDK context. Take it away, Bill.
Thank you, Richard. Welcome, everybody. My name is Bill Hollings. I'm the primary developer of MoltenBK, and I'm here to talk to you about MoltenBK as a product. We're going to talk a little bit about what MoltenBK is. I'll give you a short history of how MoltenBK came about. We're going to talk about who's using MoltenBK, talk about some of the functionality that you can find in MoltenBK and how it impacts the performance, where we are and with the current status of MoltenVK, and also where we're heading in the future with MoltenVK, so what you can look forward to. Now, this is a crazy slide, a bit of a crazy slide. I don't expect you to absorb it all. There won't be any tests on it. But this shows the current state of cross-API layering. And by that, I mean running one graphics API on top of another graphics API that might where that first API, the one that you're layering on top, is might not be available natively on a platform. So along the top, we have the what you're trying to run. So for instance, Vulkan or OpenGL, OpenCL, OpenGL-ES, etc. And then on the left-hand column, we've got the platform that you're running on. So for instance, in the first column, you'll see MoltenBK at the bottom there. And that means I'm running Vulkan on top of Metal. That's what MoltenBK does. The other logo here is another product that we developed called MoltenGL, and that runs OpenGL-ES on top of Metal. But there are a number of other combinations as well. For instance, you can run OpenGL on top of Vulkan, OpenGL-ES on top of Vulkan. You can even run OpenGL on top of DX12 or DX12 on top of Vulkan. There's lots of combinations here. Where you see a word inside a box means there's a compatibility between the layer that you want to run on the top and the layer you want to run on the left. Okay, and then furthermore, you can even layer on layers. So let's say you wanted to run OpenGL on top of Vulkan. You can use a product called Zinc there. And then you say, okay, now I've got Vulkan, so now I want to run that on Apple, so I'm going to run that Zinc layer on top of MoltenBK. So that's actually because as far as each layer is concerned, they just represent a graphics API. So moving on, this is just a brief history of MoltenBK as promised. The company I work for is Brenwill, and the Brenwill workshop, actually. This started way back over a decade ago. We were in the graphics business. In particular, we were working on iOS to develop an OpenGL ES2 game engine. And then when Metal came out in 2014, there was a lot of demand to modify our engine and have it run on Metal instead of OpenGL ES. We looked at that and decided that the entire engine was basically embedded with OpenGL ES. We had not anticipated ever leaving it at that point when we started. And we were using third-party libraries that were inextricably linked to OpenGL ES. So what we decided to do instead is develop a layer that took OpenGL and pushed it down onto Metal. So ran OpenGL on Metal with the idea that doing that would be faster in terms of performance than the native OpenGL ES driver. And it turned out to be a good bet because MoltenGL is actually faster than the OpenGL ES drivers. Now, and then after that, we took, when Vulkan came out a couple of years later, we basically said, hey, here's a new API. Apple is clearly not going to support it because they have Metal. And so why don't we do the same thing we did with OpenGLES and do it for Vulkan? And that we released the initial version of that about the same time that Vulkan came out in 2016. Then a couple of years later, we had originally started out as a 4 licensed product, and that's the way MoltenGL is still to this day. But MoltenVK got a lot of industry interest in the Vulkan industry, and Valve actually got involved and bought the source code from us and open sourced it. And then they continue to be very effective in funding my development, as well as some other development that goes into MoltenVK. At the same time, once it was open sourced, we basically donated it to Khronos, or at least put the home repository on Khronos, so that it was recognized as an industry, an ecosystem, Vulkan ecosystem environment. And at the same around that time as well, a company called CodeWeavers, who you may be familiar with in terms of running software on Mac that comes from other platforms. They got involved very heavily and started contributing significantly, and have been doing continue to contribute fairly significantly to this day. Okay, so now who's using MoltenVK? We've got this slide is interesting. This comes from LunarG's annual survey from this year, where they survey Vulkan developers, people that are using Vulkan, in terms of what they're doing and how they're getting along, as well as what they'd like to see, that kind of thing, what the preferences are. On the left here, we see runtime platforms. So these are developers that are interested in running applications or games on a particular platform at runtime. And you can see here the two that I've highlighted, macOS and iOS. Between them, they're roughly, we're roughly in the 20s in terms of 20s and up in terms of interest, and running on Apple platforms. So that's quite a significant interest in terms of, yeah, we'd love to be able to run our games on these platforms. And then on the right-hand side, we see the complement to that, which is the development platform. So who's using what platform to develop their apps? And again, you can see a small but not insignificant number of developers are using Macs to develop their games, or at least to port their games over. So again, we're talking about upwards of 15-20% of the developers are using Mac OS as part of their development suite. So significant interest from the Vulkan ecosystem. Now, this is who's using MoltenVK. This is kind of extension if you want to know who's actually involved in this and making use of it. So this is a little more detail. There's a number of games, as you can see here. I'm not going to go through all of them. You can kind of get a rough idea by scanning. We've got a series of games that are running under MoltenVK. We've got games that use CodeWeaver's crossover product, which has MoltenVK embedded. Those are games that have been ported over officially from another platform. We've got applications. It's not just games, it's also applications. Autodesk is very interested in making Vulkan their focus and using products like MoltenVK to run it on other platforms that don't natively support Vulkan. There are a number of engines, game engines, as you can see here, and even a lot of emulators as well. So these are environments where not just one game, but organizations are interested in emulating a complete, typically console environment on Mac. And all of these environments are using, and products are using MoltenVK. If you're interested in seeing an analysis, in the top right there, I've got I've highlighted a YouTube video that talks about a gamer who had deliberately gone and found 15 games that use Molten BK and actually runs them and makes some very interesting comments about performance and things like that. So if you want to actually see Molten BK in action on a number of games, that's a good link to go check out. It's called Testing 15 Games with Molten BK Support. I highly recommend it in terms of getting your feet wet with what Molten BK is capable of. Now, in terms of functionality, most games find all the Vulkan functionality that they need. Our development priorities in terms of what we focus on in Molten BK is based on developer feedback. So typically we prioritize functionality that somebody needs. You know, somebody reports this game isn't working properly. You know, we'll dig into that because we are interested in having games and emulators and engines function properly with Vulkan and get as much functionality as they can. So the focus is on definitely on developer feedback in terms of priorities. We do, at the same time, strive for Vulkan portability conformance. So there are well over 1 million tests, conformance tests. You'll hear me use it. You might see the term CTS out there. There's really 1 million unit tests that Vulkan platforms, not just ours, but the entire industry, uses to validate the behavior of drivers. And right, as you can see, there's about 1 million. With regards to Vulkan 1.0, which is the original, we are very low in terms of, very close to being fully conformant there. There are a few tests that we are still working on. In terms of all of the features that Molten BK supports, as you can see, we pass well into the 300,000s of the tests. We've got about 11,000 fails right now, and we are chipping away at that. But once again, our focus is on developer feedback. So a lot of these CTS tests conformance tests are outlier environments. They're situations that people don't normally encounter. They're very precise in terms of, does this color match what we're expecting, kind of thing. So a lot of those tests are actually more academic than practical in terms of game development. The current status in terms of functionality, we support almost all Vulkan 1.2 functionality plus a number of extensions. As you know, the main Vulkan specification is at 1.3 and has been for the past year or so. And we are striving towards 1.3 functionality. I'll talk about that in a little bit. This is an open source project with a small dedicated team. It's quite small, actually. We're working hard to minimize the unavoidable delay to integrate new Vulkan functionality. So the entire industry is moving forward in terms of Vulkan functionality and extensions, and we are doing our best to catch up. But we always look for outside contributions, people who are interested in donating some time, companies that are interested in seeing functionality appear sooner rather than later, and are willing to either contribute or fund development to make that happen. Now, in terms of performance, the performance of Molten BK is very strong. There are a number of AAA titles and other challenging, like I mentioned, Autodesk is making use of it in running products out there, existing products, and many AAA games are successfully running Molten BK with very little impact to performance on macOS. There is some minimal unavoidable overhead. It is a layer, so it is translating one API to another in real time. Metal is a bit of a higher level language API than Vulkan, and it has less fine-tuning options. So where Vulkan allows you to carve up your render paths to the nth degree, Metal does not necessarily do that in terms of a lot of the details. So where that does have a little bit of an impact, completely depends on how you're using Vulkan to see that impact. Transpiling the shaders from SPHERE to MSL, which is metal shading language, versus hand-tuned shader code. So somebody who has the time and effort to go in and hand-tune a metal shader as opposed to an automatically generated and translated shader may find it running faster. Again, we try to minimize that in our techniques for converting SPHERE to MSL. Performance issues often only show up in practical terms in particular game context, depending on how the game's use of Vulkan maps to metal. So somebody may have developed a Vulkan app that runs really well in a native driver, but when it comes over to metal, they may find that the way they're using Vulkan and how that Vulkan functionality maps to metal may run a little slower. That's the case where by retweaking how that app makes use of Vulkan, they can get better performance because there's more of a one-to-one mapping between. So the closer you can get to a one-to-one mapping between what Vulkan is doing and what metal is doing makes it beneficial in terms of performance. We are committed to improving performance whenever we're made aware of it. And again, that's a function of developers feeding back to the MoltenVK team that where they see performance and any detailed information they can provide in terms of where they believe the performance hit is occurring, helps us resolve it fairly quickly. And once again, if you are using MoltenVK or you're interested in using MoltenVK and one of your challenges that you're encountering is a performance issue, we completely welcome contributors or contributions in terms of funding to our environment. Okay, as I mentioned earlier, this is where we're sitting with MoltenVK currently. We support Vulkan 1.2 plus extensions. There's a lot of extensions that we support, and we're adding more on a fairly regular basis. We're embedded in the Vulkan SDK, which Richard will talk about a lot more, for macOS and now iOS. That's a product from LunarG. Most of you are probably, if you're using Vulkan, you're familiar with it. We are a key component to the Khronos Vulkan Portability initiative. That initiative is meant to address the differences or the challenges that layered implementations of Vulkan have. So for instance, let's say there's a feature in Vulkan that just does not exist in metal currently. We want to be able, the initiative is there. One of the things we want to be able to do is flag that to the developer who's at runtime to say, oh, on this particular platform, this particular OS, this feature of Vulkan is not available. So it's a very small number, down in the range of 1 to 2 dozen flags that we set based on whether functionality is available on this particular platform. We're currently undergoing extensive activities to reduce CTS failures, as I mentioned before. That's one of the key ways we work with understanding how Vulkan is running on MoltenVK is to run this series of over 1 million tests. Ideally, we want to get that to 0, at which point we would be able to say that we are Vulkan conformant. Also, improvements come in from bug reports and enhancement requests posted. I mentioned this several times. Please let us know when you encounter either a functionality or a performance issue. And I posted the link to the MoltenVK issues list there. It's on GitHub, and just go to the MoltenVK BK repository and open up the issues list. We welcome any issues that come along. Now, what's happening in the future? We've got we just recently added triangle fans. That was sort of a bugaboo that people would complain about. So we just finally got that going. Not that it was particularly challenging to develop, but it was more on the low end of the priority list. As you know, modern environments are trying to stay away from triangle fans, but there are a lot of legacy environments that still make use of triangle fans, and so we just added it. We are improving functionality and performance for bindless resource and descriptor indexing support via Metal 3. That's going to be coming very soon. I have down here July, but it'll actually be probably later in this month, towards the end of this month. Vulkan acceleration structures is an ongoing development that's going on right now. That'll start to introduce the initial steps for ray tracing. Transform feedback is a project that is currently being developed. Very soon we will be integrating Apple's shader converter technology. For those of you who are paying attention to the Apple's worldwide developer environment, they released two significant features regarding metal gaming. One was a shader converter that converts from DX shaders to metal shaders at a binary level. We will have to add on a binary conversion from SPIR-V to DXIL first. So first step, so it'll be a two-stage conversion, but because it's working in binary, we expect it to work much faster. Also, part of that technology, Apple now supports geometry tessellation and mesh shaders automatically as part of that product. So we're very excited about introducing that. It should add quite a bit of functionality and performance improvements once we integrate that. Also, we're looking at faster pipeline caches with metal binary archives. So right now, the archives could use a little tuning by using metal binary archives. We're looking at one of the big extensions that everybody's clamoring for is descriptor buffer. Again, that ties into the bindless resource and descriptor indexing improvements that we're doing. And finally, we're aiming for Vulkan 1.3. So there's active development. I'm highlighting that on the right here. This is a list of extensions that are required that represent the change from Vulkan 1.2 to 1.3. And we are well on the way to implementing the extensions that will take us from our current Vulkan 1.2 status to the 1.3 status. Okay, and that wraps it up. Thank you very much for listening.
Okay, thanks, Bill. My turn. So I'm going to talk about how to use MoltenVK to build Mac apps and iOS apps using MoltenVK bundled with the Vulkan SDK. So what I'm going to talk about are a few things. One is, why isn't there a native driver on macOS? That's sort of the elephant in the room. A little bit sort of talking more about, the same sort of thing Bill talked about, but at a higher level. How to ship an application on macOS and iOS, how to build your bundles, validation layers, how to use those on the Mac, and the Vulkan configurator, which is an important part of the Vulkan SDK. And very, very important, we have two very important extensions that you need to use on the Mac, the Portability Enumeration Extension and the Portability Subset Extension. And I'll talk more about what those are. And also an update on how we're going with the Vulkan Loader and validation support on iOS. The SDK does support doing Vulkan on iOS and actually Apple TV as well currently. But we don't have loader support, which means you can't use validation layers. But that is going to be changing in the near future. And I'll talk about that more closer to the end. So as you may have known, Apple sort of does things its own way. And Apple is not really a bastion of openness. They do participate in some open source projects from here to here, here to there, but when they want to do things their own way, they do things their own way, and that's fine. They're Apple; they can do what they want. They seem to be pretty successful at it, right? In the past, Apple worked with other IHVs. They supported OpenGL was the native driver hardware acceleration driver for Apple platforms. Desktop shell, everything was actually using OpenGL. But now they're using Metal, of course, and so the developer-facing API is Metal, and that is the API of the OS. If you're using any high-level toolkits from Apple or video or image processing toolkits, those are all Apple. Those are all Metal accelerated underneath the covers. And Metal is also a low-level and explicit API, much like Vulkan in some ways, but as Bill mentioned, it's not quite as low level as Vulkan, and that helps Bill earn his paycheck, figuring out how to get around those sorts of things. So since we don't have Vulkan on Apple, and a lot of us do run and write very portable, GPU accelerated applications, OpenGL was sort of the king of that in past years. OpenGL is deprecated on Apple. I really don't see how they can, in practical terms, remove OpenGL in the near future because there's so much legacy around it. But new projects probably don't want to necessarily start from scratch using OpenGL. And Vulkan is is a great option for people who want to do that. There's lots of talks here at SIGGRAPH about that as well. So how do we deploy Vulkan on Apple platforms? Well, the simple solution that Bill came up with was write a Vulkan driver on top of Metal, and ta-da, you have MoltenVK. It's a little more complicated than that, obviously. But you do not have to learn Metal. I've seen on Reddit and forums all over the place. Well, I learned Vulkan. Now I have to learn Metal if I want to do it on the Mac. Or now I have to learn MoltenVK if I want to do it on the Mac. No, you don't. It's just Vulkan. It looks exactly like Vulkan on Windows does, or Vulkan on Linux OS does. There are a few things you need to know because you're on an Apple platform. We've all seen those apps that use real high-level toolkits, and they look the same on all platforms, and they usually look awful. But if you're going to do something for the Mac, you probably want to take advantage of the Mac to some degree, and you'll probably do that in your Vulkan apps as well. But 99.99999% of your rendering code is going to be exactly the same as your Vulkan on any other platform. It's as simple as this diagram. On the left-hand side, your game is going to call your game or application. It's going to call Vulkan. The Vulkan API is implemented by the MoltenVK layer, which is built on top of the Metal API, which is, of course, really sort of the same as the GPU hardware driver on Apple devices. Anywhere else, your game's going to call your game or app is going to call Vulkan, and then it just goes right down into the GPU driver. It's the same thing. So there's a few layers that you're going to go through. Fortunately, modern CPUs are very fast, and the majority of your performance is going to happen because you're running on the GPU, you're not running on the CPU anyway. And so this works really well for most games and applications to get very good performance that they're going to need. Of course, it's never quite that simple. There's a few caveats, and that's sort of the point of this talk. Otherwise, we'd have quit when Bill was finished talking. So MoltenVK is great. Where do you get this magic library? It is included in the Vulkan SDK, which you can get at vulkan.lunarg.com. We roll a new SDK every, sometimes it's as short as 6 weeks, not very often, but usually 9 weeks, occasionally a little bit longer, 12. I think we're going to go 12 weeks. SIGGRAPH and some other things got in the way of the current SDK release. But really regular basis. Bill releases. We synchronize this with Bill as well. He synchronized a release of MoltenVK, and we'll include that in the SDK packaging as we roll out the SDK. You don't have to wait on the SDK though. It is of course an open source project, and you can go to the Khronos GitLab repo and download MoltenVK and of course build it yourself if you like to do that. So how do you package MoltenVK with your app? If you're coming from the Windows background or a Linux background, this may seem a little weird to you. Um, Generally, we don't do well. Let me back up. Let me just sort of give you the high level, and then we'll talk about each one in particular. The first way you can use MoltenVK as a developer only is to install it system wide. Just put MoltenVK in your system folders, and all your applications will see MoltenVK. All your applications will see the loader and also the Vulkan validation layers, and you don't have to really do anything special. This is only a developer type configuration. You do not want to ship your applications this way. Um, we don't do that on the Apple. We want to put things in the bundles. The more Apple-y way of doing things is to include the loader and MoltenVK, and even if you want some validate, if you need to, layers aren't always validation layers. We also have layers that do emulation, like the shader objects or synchronization too. You can include those in your app bundle, and you just ship MoltenVK in your app bundle. You can also link dynamically to MoltenVK. You put it in your frameworks folder and just link directly to MoltenVK. MoltenVK, in addition to being able to be used by the loader, it also has all the same entry points that the loader does. So you can actually treat MoltenVK like the Vulkan loader. The only thing that doesn't work, of course, is you don't get the validation layer support when you do that because the loader is not in the middle of there. You can also link statically to MoltenVK. And this way, there's no dynamic libraries at all involved. Just MoltenVK just gets statically involved. A lot of developers do like to statically link libraries. It does sometimes actually lead to smaller, faster executing code. Plus, if you are writing a application or a program that you don't want to put in a bundle, like a command line tool or utility that does Vulkan compute, you can link statically to MoltenVK and get that functionality in your application without having to have a DLL, a dynamic library, or DLL for people new to the Mac involved in your application. So for now, by the way, the last two are the only ones that are available for iOS. We don't have loader support on iOS. So either you can dynamically link to it and include it in your app bundle on iOS or tvOS, or you can link statically. In the near future, this will drop, but this is currently where we are right now. Okay, so let's see. Option number one, I want a system-wide ICD like I'm on Windows or Linux. I don't want to have to configure a build environment and bundle things and all that sort of thing. When you install the Vulkan SDK, the first option of the many optional things the SDK installer will do is you can select a global installation. That will copy it into user bin and all those public libraries and put all the headers there. This works really well with CMake. CMake can easily go out and find the packages. The loader can find the validation layers without looking in the application bundle. And it's sort of a faster development environment, if you will, for us, for developers who are just iterating on our machine over and over again. Again, we wouldn't want to necessarily deploy this way. Another great reason to use this method to have it system wide is we can use the Vulkan configurator. Again, not an end user tool. The Vulkan the Vulkan configurator allows us to surgically select which layers we want to be activated when we run our application. So we could test our application with shader object simulation, or test our application with synchronization to simulation, even though we might be deploying on Windows or another platform where that functionality isn't emulated by a layer. We can also, of course, use the validation layers, which are really, really great. The Khronos validation layer is my favorite layer. I've used it all the time to find bugs in my code, bugs I don't know about. If you've been developing software for more than, say, 3 days, you know how it is where you get a bug will show up, and when you finally find the bug, you're like, how did this ever work to begin with? So all of our code has bugs we don't know about, and this helps us find those bugs ahead of time. Now I'm talking about Vulkan API usage bugs. It's not a debugger for normal development, but what the validation layer does is it watches every Vulkan function call. And if you call a function call with an invalid parameter of some sort, or you've not set state up correctly before you use a certain Vulkan feature, you'll get on your standard out, you'll get a validation error. It'll say, hey, you've violated this rule, and it'll even tell you what it was what rule was broken, and will help you find it. I'm a very old school OpenGL developer, and I remember the days putting GL get error sprinkled in my code and hoping if one of them triggers, then I would be able to figure out eventually which function call, had generated the OpenGL error. This is a dream come true in comparison to those days, as far as finding bugs in your rendering code. There are also a lot of layers that we do ship on macOS. We don't have debug printf and GPU assisted validation. We're working on that. There's some things we need. There's some holes in metal that we might need to work on. But by and large, the Khronos validation layer does work. We also have synchronization 2, which is an emulation layer. It basically provides this support, even though metal doesn't. I should say, even though it's not implemented in MoltenVK, whether it's Metal's fault or somebody else's, I don't know. But that feature can be emulated there in that layer. Shader objects, brand new extension, gaining some popularity, is also emulated. We also support the Khronos profiles and API dump if you want to make use of that in your development time. So what does your app look like when you bundle it on iOS? Now, we'll talk about iOS in a few minutes. iOS looks a little bit different from this. If this were a live studio, I'd say how many of you are new to macOS? If you're not new to macOS, you know what this is. If you are new to macOS, it may come as a surprise to you that we don't ship like an executable and then a folder that has to get copied into a certain location. On macOS, we have these app bundles, and all an app bundle is a folder with a special extension .app. Clever, right? And it also contains subfolders, and that folder contains everything you should need to run that app, except of course for system-wide libraries. So let's say I have this awesome Vulkan program called Vulkan Rocks .app. The first folder in all of our app bundles is contents, which is the contents of the application. There's a frameworks folder and a macOS folder. And due to the way Apple enforces their security policy, these are the only folders executable code can go in. So if you have a dynamic library or a framework, it has to go in frameworks. And binaries go in macOS, something that gets executed. There's also a plugins folder, but this isn't a general Mac lecture, but you can also put stuff in the plugins folder that's executable. But there's a resources folder, and resources can contain no executable code. This is all data, images. You can put scripts in there. Scripts technically are executable. It depends on sort of like Democrats and Republicans, right? Are scripts executable? We could probably start a big fight about that. But anyway, down in resources, we have some files that we're going to need. We have Vulkan ICD.D. D stands for directory, and then the MoltenVK ICD.json. This is sort of a very Vulkan, sort of what Vulkan does on other platforms. It's sort of warped a little bit for application bundles. This JSON contains some information about the Vulkan implementation. There's one of these for each ICD. MoltenVK isn't the only ICD you could use on the Mac. There's also Swift Shader, which is a software implementation of Vulkan. There could be more down the road. So I might have a MoltenVK ICD. I might even have a Swift Shader ICD. And then up here in frameworks, I'd have my MoltenVK library, and I might have my Swift Shader library and so forth. I also have the Vulkan loader here as well. So when your app starts up, it's linked to the Vulkan loader. The Vulkan loader is going to look over here to find out that the live MoltenVK is here, and then it loads MoltenVK as your installable client driver for Vulkan. And of course, if you have any layers, they also have to go in the frameworks folder. So there is a white paper on the LunarG website. Now, a word from our sponsor, right? On getting started on the Mac that also goes into more detail about how to do all of this stuff. Another option, I did say there were four, you can just include it as a dynamic library, and there's really nothing fancy to talk about here. You just simply put the MoltenVK in frameworks and link directly to MoltenVK instead of linking to the Vulkan loader, and it will just simply automatically start running MoltenVK and all of your um, all the Vulkan API things that you need are there. This works on all Apple platforms, desktop, iOS, and Apple TV. It does bypass the loader, so you don't get validation layers, but it's a great way to ship an application. If you don't want to ship your application with any layers installed, then you're good to go. The third way, or the fourth way, and the final way is the statically link MoltenVK. This is a great way. It works really great, especially for, like I said, command line programs or a program with it, or a utility program that goes in the bundle with a bunch of other utility programs. You just simply, in the SDK, we include a MoltenVK XC framework. It's a fancy framework from Apple. It contains binaries for macOS, iOS, and tvOS. And it also includes the binaries for the simulator, so you can simulate them on your Macintosh. Macintosh. That sounds old school right there. Who says Macintosh anymore? They're Macs. All right, so also can't use layers when you link statically, but that's fine. A lot of applications don't need to ship with layers. Utility layers are great, and they're very popular on Windows, but I'm actually not aware of too many people using them on the Mac, although they are there. And it could just be a marketing thing, a branding thing, right? Or people aren't aware that you can ship layers in your bundles. You certainly can. Okay, so that's basically how we package MoltenVK and the Vulkan loader and ship that on macOS. What about the code? You said something about some fancy extensions, Richard. Yes, two extensions that we absolutely need to pay attention to. There's the portability enumeration extension, which is an instance layer. An instance layer extension, and then the portability subset, which is a device layer, device level extension. These were, I think I can get away with saying this, but these were more or less created for MoltenVK. And in the idea that MoltenVK sort of made the Khronos guys, go, hey, you know what? There are going to be a lot of Vulkan implementations layered on top of other APIs. And it might not just be the Mac. People might want to do that on Windows or on Linux, like say put implement Vulkan on top of DirectX 12, for example, which Bill was talking about. And when you layer Vulkan on another API, there may be holes in the functionality. And wouldn't it be great if when you said, hey, your code says, give me a Vulkan device, if your code had a way of going, are you really a Vulkan device, or do you have shortcuts, or are there holes in your functionality? And if it has holes in the functionality, I might want to say, well, I don't want to run on you at all. I need a fully conformant Vulkan 1.3 implementation, and I'll accept nothing else. Or your app could go, oh, you don't have triangle fans. Well, I don't care. I got a great code path that works without triangle fans. I can run fine on a portability implementation. And so that's what these extensions are designed to allow you to do. It's allow you to go, hey, am I running on Mac or Windows or am I running somewhere where I have a portably compliant implementation that has well-defined and documented holes in functionality, or am I running on a full conformant Vulkan implementation? And that's what these extensions are going to allow you to do. So first, we have the portability enumeration extension. This is provisional, it's subject to change, which we all know, again, means it will change probably. Now, as I was mentioning a minute ago, another real reason for this is to prevent games. This actually occurred on Windows quite a bit. There were some Vulkan ICDs back in the day when I was a young man. We had something called quick drivers. OpenGL was very popular, and people would make these OpenGL wrappers that implemented just enough OpenGL to run Quake. And then somebody else would have an OpenGL program and they would go, well, let's run it on the Quake driver. And it wouldn't work because they used functionality that the Quake driver didn't support. I should probably quit saying Quake driver because it was a very derogative term at the time. But you get the idea. If your games goes out and it finds a driver that it won't work with, the game crashes. And we all know what happens when the game crashes. The consumer who bought the game, whose fault is it that the game crashes? They don't want to hear that it's a driver. They don't want to hear that they installed something weird on their system. It's your fault. You wrote the game. It crashed on my system. It's your fault. So yeah, vendors, you guys, you don't like that, right? So that's sort of what the purpose of this is. This is beyond just the Mac or the Apple environment, is to go, does this implementation of Vulkan have everything that I need in order to run? All right, where are we on my slides? Here we go. So how does this work? It is an instance extension. You have to tell the loader. So you may be new to Vulkan, you may not, but one of the first things you have to do is you link to the Vulkan loader and you say, hey, loader, do you have some Vulkan devices? And the loader will say, why, yes, here's a list of Vulkan devices. So what the portability extension allows you to do is say, hey, loader, I want a list of devices, but I don't want anything that's portable. Or you can say, hey, loader, I want a list of devices and I want everything, even if it's got a portability extension. And so you add this KHR portability extension list to your list of extensions, instance extensions that you want when you create the instance. If you use this, there's also a flag you have to set. I'm going to show you some pseudocode in a minute. Don't panic. Where you have to say, hey, I want also portability implementations that are on this system. If you don't do this, and there's a portability implementation and a full-blown implementation, you'll only see the full-blown implementation. You won't see the portability implementation at all, which means if you do this on the Mac and all you have is MoltenVK and no other implementations, you'll get error incompatible driver. It'll go, there's no driver here. I don't see anything that I can make use of here, which is just what I told you. I got a little ahead of my slides. We're not going to worry about that. And okay, so again, ahead of my slides. Here's some code. All right, saved by the code. So this is typical boilerplate code. Whether you're following Sasha's Vulkan samples or anybody else's samples, you're going to call enumerate extension properties with a null pointer to find out how many extension properties there are, which is basically a list of instance extensions. And then you call it again. And so it'll fill in this, it'll fill in your vector with a list of all the extensions. Now you go through there and you look and you go, hey, do you support this portability? Get my mouse over here. I can't get my mouse over there, but you can see it. Let me say, if this portability enumeration extension exists, it means you have a new loader. Good. You've got a fairly up-to-date Vulkan loader, and it knows the difference between portability implementations and non-portable implementations. And you can tell it, okay, hey, I want that in my list. And so when you create your instance, we're gonna add that to our enabled extensions names list. We're going to add this flag that we want our portability extension portability implementations listed as well, and then we're going to call create instance. If you get error incompatible driver, it means that there's only a portability implementation there, and you told it you didn't want one, or maybe you didn't set the flag and you didn't set up the extension correctly. Okay, so let's say you did all this. And the loader gives you a list of devices, which on the Mac, most of the time, it's only going to be one, especially since you're shipping the app bundle. And you probably included MoltenVK in the app bundle. So you're probably already aware there's only going to be one implementation. But now what do you do now that you have it? Now we need to use the portability subset extension. And what this extension does specifically is you can query the device and you get a list of features that may or may not be available on this device. So you might be running on a brand new M1 Mac, I should say brand new M2 Mac, or you might be running on an old busted Intel Mac with, maybe you've got an Intel integrated and a NVIDIA or an AMD um, GPU. Oh, you know what? That's very important. I should talk about that. MoltenVK is an ICD, but when you enumerate devices, the Vulkan loader is going to see both the Intel integrated GPU and it's going to see the NVIDIA or AMD GPU, and you will have two devices to query between. And MoltenVK may even act differently. And we'd have to ask Bill about this if he knows of any examples, but it may even act differently between the two. There may be some things, who knows? Maybe the NVIDIA card can do that Intel can't do. I don't know, could happen, right? And so this list of features may vary depending on the device. And so you might want to set your code up to query both of those devices. But I'm going to show you how to query a device and get that list of features back out using this portability extension. It is a device extension. When you call enumerate device extension properties, you're going to be looking for this KHR portability subset. And you're going to need to add that to your list of extensions when you create your device. So here's sort of kind of what some code would look like. You would enumerate all of the extensions, and then when you loop through the extensions looking for the ones you care about, you would look for the portability subset, and if it's there, add it to your list of extensions. It's important you do that because functions we're going to call in a minute won't work if you've not added this extension to your list of desired extensions. So here's what you're going to do. You're going to call, there's a data structure called physical device portability subset features. This is part of the extension. So this extension rides on the back of physical device features too, which is another extension. It's now part of the core Vulkan 1.1 spec, and so we don't have to look for it. But the portability features goes into the pnext of your device features structure. And then when you call get physical device features, not only does it fill in the standard device features, but it also fills in the portability device features. And that looked like this. And so things like down at the bottom, triangle fans, or, do you support events? I've seen some of these change in my time as a Vulkan developer working at LunarG and a little piddling before that even. And I can tell you that this is definitely very provisional because triangle fans is about to turn on. It's already in the MoltenVK GitHub repo. The very next Vulkan SDK that gets released will include that. And this flag, triangle fans, will suddenly come on. So bear in mind that you can't, just because these are set a certain way on your machine, that's going to be that way on users' machines forever. Also, bear in mind that these could change based on the version. You should assume these could change based on the version of the OS or the generation of the Macintosh or computer that that your end user is making use of. Now, it's not enough. This will give you a list of the things you want. If you've used the physical device features 2 extension, then you know that tells you what features your implementation of Vulkan supports, but you also have to tell it which of those features you're interested in when you call create device. And these portability features are part of that. You have to make sure you include a pointer to your portability features to the device create info. Okay, so that's pretty much it. That's how we bundle MoltenVK, many different ways to bundle MoltenVK with our applications before we ship them. And how we, in our code, we have to take into account that we might be running on a not fully conformant Vulkan implementation. How about running on iOS and really tvOS as well? Well, the MoltenVK has always supported iOS and tvOS. I don't know if it's always supported it, but it has supported it for as long as I remember, which has been quite a few years now. So you could always build applications on your Mac desktop, and you could always link to MoltenVK directly and deploy it on iOS as well. But what we've really been wanting for a while, and what developers have been telling us that they want for a while in their, in our surveys, is they want the loader on iOS so that they can use validation layers or layers in general to simulate other functionality, and they want that available on macOS. So we're working on it. The time frame is to be determined. We are aiming for before the end of the year. Currently in-house, we have the loader actually working, and layers do work. It's only explicit layers though. So iOS is, it's even more locked down than the desktop. We can't install layers in a system location. They have to go in the app bundle. So there's no implicit layers on iOS. It's not even an option in developer mode. There's also no VK config. So we can't easily have a separate program that's changing how our device works. We could probably do that if we put enough engineering time into it. We'd probably break all sorts of rules. You wouldn't be able to ship it that way, and Apple would probably shut it down with the very next OS release anyway. So this is sort of where we are. So that's okay though. We can programmatically say, I want to use this layer. We can put the layer in our bundle. And the validation output goes to std out, which we can capture with Xcode, or if you're on Windows using one of the mini tools, they also capture std out, and you can get your validation output. If you've never seen how to turn it on in code before, this works on the desktop as well as iOS. We simply make a list of layers that we want. For example, the API dump, and when we create our instance, we add that to our PP enabled layer names member of the create instance info structure. And it will find that layer and load it. Now, if the layer is not there, if you can't find it, the instance won't create, by the way. You'll get an error code, which actually, if you follow the error code into the headers, it goes layer not found. So make sure you turn this off in shipping code if you're doing validation, or make sure you've left it on if you're doing some sort of emulation or something else using a Vulkan layer. Packaging on iOS is a little bit different also than it is on the desktop. We still have app bundles. They're not as deep though as they are on the desktop. We have a frameworks bundle where you put your framework and your dynamic libraries. A common thing that I keep coming across when I first started, Googling around for this, dynamic libraries have to be in a framework. That's not true anymore. It was true in the very recent past, so there's still a lot of information on the internet about that. But you can't put a dynamic library, a raw dynamic library, in your frameworks. It does have to be signed by you, though. They're not gonna. There's no free lunch, right, in the Apple world. Your application binary just sits right at the root of the application bundle. If you have a VK layer settings file to affect the settings of the layer, this is where you put it as well, right at the same level in the bundle. And then we also have a Vulkan folder. This didn't line up exactly the way it should on the slide. Don't be too misled, but frameworks, Vulkan rocks, and Vulkan down at the bottom are all at the same level. You have ICD, MoltenVK. That's pointing to your ICD. We also have an explicit layer.d folder. Again, this also goes under Vulkan. And this is going to be the JSON for your layers that points to where the layers is, which is right up here in frameworks. Okay, so in conclusion, MoltenVK is a layered Vulkan implementation. It's not a separate thing. It's not a new API you have to learn. Everything is Vulkan. Even the whole portability thing, that's not MoltenVK. That's just Vulkan. And that may be just as important on other platforms besides macOS in the very near future, if not already, as well. You can work around missing extensions and features like any other platform. I do kind of a lot of systems level stuff at LunarG, but I've spent decades as an application developer. And I can tell you, everybody, everywhere, every single time, you're working around platform things. I mean, it works on NVIDIA, but it doesn't work on AMD. It works on NVIDIA and AMD, but it doesn't work on Intel, and you're going to put code paths in there anyway. I can tell you that's a pain. That's part of the cost of being an application developer. But I also say it's actually, for all the grief Vulkan gets, it's actually a lot easier under Vulkan than it was in the OpenGL days. You can beat me up afterwards if you want. Actually, don't beat me up, but maybe buy me a Starbucks. All right, we have two portability extensions we need to help with. That's going to help us navigate this, feature morass. And performance is still very good. A layered implementation. It's not like a giant translation layer. Yeah, I know it's translating, but it. If you look at it, sometimes engineers get really, really overwrought about 8 more processor cycles about something that happens one time during your entire game. If it's 5,000 processor cycles every single frame, I might worry about it. But benchmark this before you go. Well, that's got to be slow. You might be surprised how well it runs. Full layer and loader support is coming soon to iOS as well. And try it. You might like it. I think you will. You're all here for Apple ecosystem. A lot of you are Apple developers or future Apple developers. So I think this will work out real well for you. Some resources. This presentation, if you want a printed version of it, you can get it at the thing on the left. Just hold your phone up, zoom in on it, click on the little thing that comes underneath of it. There's also a white paper, State of Vulkan on Apple devices. That is my white paper at LunarG, and I'm probably going to revise that again before the end of the year. There's at least 2 revisions I need to make to that when we get the loader and stuff working on iOS. That'll also be an important revision. But that's a good place to bookmark. Go back and check it every few months and see if we don't have some new information about things going on Vulkan on Apple related. And if it's SIGGRAPH is over, sorry. If they're recorded, there's also a good birds of a feather Vulkan Forging Ahead that you can go to. And I will be demonstrating this at SIGGRAPH. I'll be demonstrating vkconfig on the Mac, showing how we can easily switch between layers and get diagnostic output when we run our Vulkan code. And I'll also be showing live API dump running on an iOS device. So layers running on the device, working great. So thank you very much. And see you in the World Wide Webs.